Hello, calculus students. Yay, math. All right, antiderivatives. Antiderivatives are just derivatives going backwards. So if f prime of x is equal to 3x squared, then f of x would equal what? Well, you could probably just do this one in your head. F of x would equal x cubed. Or does it equal x cubed plus 1? Or does it equal x cubed minus 8? Because if I derive x cubed, that gives me 3x squared. If I derive x cubed plus 1, that gets me 3x squared. X cubed minus 8, that gets me 3x squared. Which one is it? So what we really have to do here is we really have to put f of x is equal to x cubed plus c. Plus c. C stands for some constant. And you don't have to use c. You can use k if you want to. But yeah, c stands for some constant. This is called the general solution. And we will learn how to find what c is in a little bit. But one of the most important things I can tell you is this. Don't forget the c. And at some point in the past, we had someone that really loved cookies. And so we decided to call this cookies. Don't forget the cookies, because I can't think of anyone who doesn't love cookies. Don't forget the cookies. The plus c is so important. Don't forget it. Okay? If you forget it, you're going to die. All right. So, down here, this is just kind of the notation that we use. If you, so dy dx, we know that that is f prime of x. If I multiply both sides by dx, I get this. And then, how do I undo the dy? Well, we use this symbol here that's called an integral. And I've been told that this is actually supposed to look like an S for like a summation. Okay, it just means adding things up. And that's important. We'll get to that. But you don't need to worry about it for right now. But this is just the notation. Now, some of you might say, Mr. Kuhn, we're using f prime of x here. What if it was the integral of f of x? It's like f prime of x becomes f of x. What if I'm going backwards? I'm given f of x. What's the antiderivative of f of x? Well, that would be big capital F of x plus c. And what do you do after that? I don't know. You redefine the function, call it something else that you can antiderive, or call it the integral. I don't know. Anyway, over here we have the power rule. So the integral of x to the n dx is 1 over n plus 1 times x raised to n plus 1 plus c. Don't forget the cookies. Now some of you are saying, Mr. Kuhn, does it have to be plus c? Can I put minus c? You can, but I say plus c because the c could be something negative, like -2, and so that's fine. We just tend to use plus symbols because they're easier. Let's check this though. If I'm deriving x raised to n plus 1, well, if I'm taking the derivative of that, down in front, I bring whatever the exponent was, n plus 1, and bring that down in front. Then I have x raised to the, I subtract 1 from the exponent. It was this, now it's this. Now don't forget, we've got this constant out in front, 1 over n plus 1. Well, hey, guess what? Those cancel out. N plus 1 minus 1 is x to the n. And this is a very good thing to do. After you derive something, check yourself, derive it, and see if you get what the original problem was. Okay? All right, down here, what is the antiderivative of 5x? Well, we can do this a couple different ways. What I'm going to do, though, is I'm just going to kick the 5 out front for now. It's a constant multiplier. And now I'm going to apply the power rule. So 5. This is x to the 1. So that means it's going to become 1 plus 1 up here. 1 over 1 plus 1. Plus c. And this will seem tedious at first, but pretty soon you're going to get it. So it's 5 times 1 over 2 x raised to the 2 plus c. We'll simplify a little bit. 5 over 2 x squared plus c. And if we do a quick check, derivative of c goes away. Derivative of x squared would be 2x. So that would be 2x. And then 5 over 2, those cancel out, like left with 5x. Bingo. This can be rewritten as x raised to the negative 3. Well, let's see here. So I got to do 1 over n plus 1. My n is negative 3, so it's going to be 1 over negative 3 plus 1 times x raised to the negative 3 plus 1. So, don't forget the cookies. Put the plus c, and that's going to be 1 over negative 2 x raised to the negative 2. Woohoo! And if I derive this, to bring this down in front, and that would cancel out there, and I subtract 1, that would be negative 3, and I'm right back where we started. The integral of the square root of x. Well, let's see here. I'm going to rewrite this as x to the 1/2. And then I got to do the process again. Okay, so 1 over 1/2. Oh, woohoo! You caught it, didn't you? 1 over x raised to the 1/2 plus 1. Now 1/2 plus 1, that's really 3/2. So it's 1 over 3/2. And I could leave it like this, but I'm going to go ahead and simplify it. So that's going to be 2/3 x raised to the 3/2 plus c. Okay, so the concept here is not super hard. At least I don't think so, but I think it's just going to take you practice for a while. So if you're having trouble with it, it's mostly just practice. Just keep practicing with these. Here we're just kind of processing antiderivatives. There's no grand new idea. It's just practice going backwards. That's all it really is. And going backwards can be difficult. I mean, everyone knows that driving a car backwards and back into spots is hard at first. It's a lot easier to go forwards. So yeah, just keep practicing. No major, huge new concepts here. Couple more examples for you. Oh, here we have some other constant in there. Well, that's all right. We're okay. We can still do this. So this is x to the 1. There's nothing here, though. That's just some I don't know, some constant. Well, if I just think of this as 7, if I just think of it as x to the 1 plus 7, well, the derivative of x to the 1 would be, the antiderivative of x to the 1 would be 1/2 x squared plus 7x, because the derivative of 7x would just be 7. Now there's a k in there. That's okay. K is just some constant. And I still have to put plus c. And that's it. That's all I got to do there. I don't want you to freak out if you see some unknown constant in there. This one, though, this one is going to take a little bit of thought. So here's what we're going to do for this one. I am actually going to divide and conquer. I'm going to split up the denominator. So it's going to be 2x over the square root of x plus 5 over the square root of x. So I decided to divide and conquer. Now, x divided by the square root of x, that is really just 2 square root of x. Plus 5 divided by the square root of x, well, I can rewrite that as 5x to the negative 1/2. And I can rewrite it again as 2x to the 1/2 plus 5x to the negative 1/2. And then I just have to use my power rule. So this is going to become x to the, if I add 1 to half, I get 3/2. So I'm going to get 2, so I got the 2 out in front, then I'm going to get 1 over 3/2 plus 5. Then I've got x to the, well, if I add, let's see here, if I add 1 to negative 1/2, I get positive 1/2. And then I got 1 over 1/2 down here, and we can't forget the cookies, of course. Now, you can leave it just like this if you want to, but I don't want to. I'm going to live dangerously. This is really 2 times 2/3 x to the 3/2. Plus 5 times 2x to the 1/2 plus c. And I'm going to rewrite this. My final answer here is going to be 4/3 x to the 3/2 plus 10 x to the 1/2 plus c. So that took some effort. That took a lot more effort, but still no major new concepts there. On this one, I don't think you know what the antiderivative of sine of x over cosine squared of x is. So we're going to, in the words of our favorite pre-calculus teacher, frolic along here. We're going to do a trig proof. Yay! And I'm going to rewrite this. I'm going to rewrite this as 1 over the cosine of x times sine of x over cosine of x. And you're saying to yourself, Mr. Kuhn, how does that help me? Well, because 1 over cosine of x is really secant of x. Sine of x over cosine of x is tangent of x. And I can rearrange this again as tangent of x times secant of x. And as you all know, it's right at the forefront of your mind, you know that the derivative of tangent of x secant of x is, the antiderivative of tangent of x secant of x is secant of x. Plus c, don't forget the cookies. So, yeah, I'm guessing you probably forgot the derivative of secant of x. That's fine. Don't forget, they're in the front of your book. That is one you have to know, though. You have to know this. You have to know the derivative of this is this. Non-negotiable. You also need to know the derivative of sine, derivative of cosine, derivative of tangent. Okay. Now, though, here's where we get to the super fun stuff. Finding an exact solution. So we can't find an exact solution unless we know at least one point on the original function, f. So if f prime of x is equal to 2x minus 5, And I got to find f of x. Well, let's see here. 2x minus 5. That becomes x squared minus 5x, because the derivative of 5x is just 5, plus c. Okay. So this is f of x. Now they tell us f of 1 is equal to 3. Now we're in business. F of 1 is equal to 3. So that means 1 squared minus 5 times 1 plus c is equal to 3. Well, man, now this is easy. 1 minus 5 plus c is equal to 3. Well, minus 5, that's negative 4, plus c is equal to 3, so c is equal to 7. So for this problem, find f of x. F of x is equal to x squared minus 5x plus 7. So we're going to use whatever number they gave us, plug it into our f of x to find that c value. Okay. And got one more for you here. A particle on the x-axis has a velocity of v of t is equal to 3t squared plus 4t minus 5. At t equals 2, its position was x equals 3. Find an equation for its position, x of t, at time t. Okay, so to go backwards from velocity and find position, I need to antiderive. So by the way, don't forget your dx's or your dt's. I'll talk about in class why not eventually, but if you forget them on a free response question on the test, I will take off half a point. Okay, so the antiderivative velocity is the position function plus c. So let's see here. Let's derive this. Antiderive. 3t squared plus 4t minus 5 dt is equal to, let's see, antiderivative of 3t squared, that would be t cubed. That one's pretty easy. Antiderivative of t, or 4t, well, that would be plus 2t squared. Derivative of what gives me 5, so that's going to be 5t plus c. So x of t is going to be t cubed plus 2t squared minus 5t plus c. Where do we go from here? Well, we're going to plug in the t equals 2. X of 2 is equal to 2 cubed plus 2 times 2 squared minus 5 times 2 plus c is equal to, position was 3. All right, so I've got 8, I've got another 8, that's 16 minus 10 is 6, plus c is equal to 3. And so c is going to equal negative 3. So my function is x of t is equal to t cubed plus 2t squared minus 5t minus 3. There we go. And that's how you do antiderivatives. Biggest things I can tell you from this, don't forget the plus c. Do not forget the plus c. Sometimes you have to divide and conquer. For a lot of the basic ones, These are just going to take some basic practice. Just lots of practice till you get more comfortable with it. And just as a reminder, the antiderivative of cosine of x is sine of x, and the antiderivative of sine of x is negative cosine of x plus c. And again, how can we check this? Well, what's the derivative of cosine? It would be negative sine. But a negative sign and a negative make that positive. So there you go. All right. There's your notes on antiderivatives. Thanks for watching.